So we want to do another example of finding a regression line. So this is the old skyscraper example that we looked at when we did correlation. So here's the deal. You have two variable data, x and y. X represents the number of stories that skyscrapers have, and y represents their heights in meters. So for example, a 40-story skyscraper here is 122 meters in height, all the way up to, let's see, the last one, 102-story skyscraper is 420 meters in height. So what we want to do, first of all, we want to determine the equation of the regression line for this data set. So when you're finding the equation of the line, we're going to call it y with a hat. That's the predicted line, equals mx plus b. You're going to have to find m, and you're going to have to find b. So we'll start by looking for m, right? M is going to be s xy divided by sxx. Maybe I should call sxy purple. sxy purple. So I'm going to focus on my sxy. Remember, that's the sum of the xy's minus the sum of the x's. Minus the sum of the x's times the sum of the y's. Okay, let me get my colors right. I can't remember. I think the sum of the x's I was using baby blue on. Yeah. Sum of the xy's minus the sum of the x's times the sum of the y's divided by, I'll use purple, divided by n. Okay, so that means we're going to have to come up with a column called xy here. So to find the xy column, we're going to multiply the x and the y values together. So first of all, 4 times 122 is our first task. 4 times 122 is 4,880. Then we're going to do 48 times 150, 7,200. 65 times 202, that's 13,130. 72 times 230, that's 16,560. Then 76 times 255, that's 19,380. We got 80 times 250 is 20,000 exactly. 84 times 260 is 21,840. 90 times 300 is exactly 27,000. 95 times 288, 95 times 288 is 27,360. And 102 times 420 is 42,840. So what we're going to have to do is add all this up. So we're going to put a little summation symbol here, summation symbol. So we're going to add up the x's, add up the y's, and add up the xy's. I'll first add up the xy's. When I add up the xy's here, xy column, I add up all those numbers. I've done this in advance. It's 200,190. When I add up the x's, I'll use the baby blue color for the sum of the x's. That's going to be, so add up all the x values in the x column, 752. And I add up the y's, it's the orange. Add up all the y values in the y column is 2,477. 2,477. Okay, so let's plug these into our formula for SXY. SXY equals, so the sum of the xy's, that's the first thing we do, is 2,190 minus blank times blank divided by, what's the sample size here? How many points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is divided by 10. N is 10. You have 10 sample points. What is the sum of the x's? We want to plug in for the baby blue color. The sum of the x's is, we said 752. So we're going to put 752 right there, where the sum of the x symbol occurs. Now the sum of the y's, that's the orange symbol. Sum of the y's is 2,477. So let's put in for orange 2,477. Okay. So we're going to calculate all this. We're going to have what? SXY equals 2,190 minus, so if I take 752, multiply it by 2,477, and divide that all by 10, I'm going to get 186,270.4. And then I subtract 200,190 minus 186,270.4, and I get my SXY. SXY is going to be 13,919.6. So for M, so far we got, for the top number, SXY, we got 13,919.6. Now we have to find the bottom number, SXX. So let's work on finding SXX. Maybe I'll do that on the side here. I'll do that on the side here. No crap. Oops. I get this pen to work. It's not. There it goes. And put SXX right here, right? That's what we need next. So remember what this formula is. It's the sum of the x squareds minus the sum of the x's squared divided by n, the number of sample points. So we have to come up with, we already have the sum of the x's. We got to come up with the sum of the x squared. So we have to come up with an x squared column. So how do we get an x squared column? Well, you're going to square all the x's. So I'm going to square 40. I square 40, I'm going to get 1,600, 1,600. Square 48, I'm going to get 2,304. Square 65, I'm going to get 4,225. Square 72, I'm going to get 5,184. Square 76, you get 5,776. Square 80, I'm going to get 6,400. Square 84, I'm going to get 7,056. Square 90, I'm going to get 8,100. Square 95, I'm going to get 9,025. And square 102, I'm going to get 10,404. So I'm going to add that column up to get my sum of my x squares, and what will I get when I add those numbers up? I've done this in advance, so I already know 60,074 it looks like. 60,074. So for finding SXX, I'm going to take the sum of the x squares, which is 60,074, and subtract blank over 10, right? The sample size is 10. What are we going to put in place of the blank? The sum of the x's. The sum of the x's we found was 752. So here I'm going to put a 752 in place of the sum of the x's. So doing this computation, we're going to have SXX equals 60,074. 60,074. Okay, I missed a 0 in there. I dropped it by accident. 60,074. Minus, so what's 752 squared divided by 10? 752, and we square that, and then divide that by 10, and we're going to get 56,550.4. And then we subtract to get SXX, and that's going to give us 3,523.6. So that's going to go into the bottom of your M formula. So SXX was 3,523.6. Come on, right. 3,523.6. Okay, so now to find M, you just divide those two numbers, 13,919.6 divided by 3,523.6. And what happens when you divide those? Let's take it to 4 decimal places. I'm always going to take my my m, 4 decimal places. When I divide those two numbers, I get about 3.9503. 3.9503. Okay? So that's my m. That's my m right there. So what we have to do now is find the b. Find the b. Remember what the formula for b is. B is equal to y bar, which I'll use orange for y bar, minus m times x bar. So we already know m, we just have to find what y bar is and x bar is. So we'll find, let's find x bar first. X bar is going to be, you add up all the x values, the sum of the x's divided by n. That's going to be, what's the sum of the x's? 752 divided by the number of points here, 10. So x bar is equal to 75.2. Okay. Now we need to find y bar. What's y bar? It's the sum of all the y's. You add up the y's and divide by the number of points. That's 2,477, right? That's the sum of the y's divided by 10. Y bar is going to be 247.7. Okay. So we're going to plug those into the formula for b. Oh, let me rewrite my b formula. I didn't give myself enough space here, did I? Should have given myself more space. So let's write our b formula. Where are we going to write our b formula? Oh, crap. It's not working. There it goes. So b, we said, is y bar minus m x bar. Let's see if we can plug in. B equals, what was y bar? 247.7. Minus m is going to be 3.9503 times x bar. What was x bar? 75.2. Okay, now let's calculate that. I'm just not giving myself enough space, am I? Okay. I guess I'll go here. Draw a little arrow. If you do that, so what you're going to have to do, you're going to have to multiply 3.9503 times 75.2, and then subtract that from 247.7. And if you do all that, you should get negative 49.4, roughly. Negative 49.4. I'm going to take the b always to 1 decimal places. I'm going to take my slope to 4 decimal places for accuracy, and my b to only 1 decimal place for accuracy. So negative 49.4. Okay, so let's write down our equation now at the top. We have y hat equals m. In place of m, I have 3.9503 x plus the b that we just found. So when you add b, that's the same as adding a negative number is the same as a minus 49.4. So here is the equation of the predicted line, the regression line. 3.9503x minus 49.4. Okay, so the next thing we want to do, we want to estimate what y would be when x is 82. So notice here, that there is no 82 for a number of stories on a skyscraper, right? You go from 80 stories to 84 stories, but we want to predict how many meters tall an 82-story building would be. That's our next step. So let's estimate. So part B, estimate. If I can spell the word estimate, that'd be great. There we go. Estimate y when x equals 82. So when you have 82 stories, how many meters tall would you approximate the building to be? So let's remember our formula. What was our formula? Our formula was the predicted y value, y hat, is equal to, what was m? 3.9503. X. And then we had a minus here. Remember the minus. What was the minus? Minus 49.4. So what I'm going to do, I'm going to plug in place of x, I'm going to put 82. So we're going to have 3.9503 times 82 minus 49.4, and we're going to calculate that in our calculator. So here goes. I'm going to do it in my calculator. 3.9503 multiplied by 82, and then subtract from that 49.4. You get about 274.5. Now I'm going to leave that as a decimal because when you're dealing with meters, right, when you're dealing with distances or lengths, you can have decimals. Now before, when we were dealing with like rainy days, you couldn't really have parts of days, so I just rounded it to a whole number. But in this case, it's fine to have a decimal. So 274.5 meters, roughly, would be the approximation. Let's do a part C here. Let's try to graph the scatter plot and then sketch the regression line. Sketch a scatter plot of the data along with the regression line. So let's go back and look at our data. So the smallest x value was 40, the largest was 102. I'm gonna go by tens. Tens on the x's. And on the y's, I'm gonna go by, goes 1, 22 to, for 20, maybe I'll go by 50s. I'll go by 50s. Okay. So here's x down at the bottom. X represents the number of stories. And y represents here on the side the height in meters. And I said probably I'll go by maybe tens. If I can do that. I might have to go a little smaller. My tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. I think I can spread this out a little more. Let me try going 10 like that, then 20 like that, then 30, 40, 50, 60, 70, 80, 90. So you can squeeze all the way to 110 here. 100, I'm going to go up to 110. Why am I going up to 110? Because remember, the highest x value I had was 102. I want to go over 102. Okay. What do I want to do for the y's? We're going from 122 to 420, so I'm going to go by 50s maybe. Think about how I want to do that exactly. Maybe 50. That would be 0 there. Then we need to have 100, and then 150. And then 200, and 250, and 300, and 350, and 400, and 450. We're not going to go beyond 450 because the maximum y value that we have is 420. You look right there, right? Okay, so let's plot these as points if we can. So this is not the same scaling on the x as the y. That's okay. You don't have to have the same scaling on the x as the y. All right, so my points. If you go back and plot all these points, the x, y's, we start off with 4, 1, 22, and so on and so forth. I'm not going to keep referring. I'm just going to plot the points. 40, 122 rather. So I go to 40, 122. That would be about here. Then 48, 150. 48, 150 would be about right here. Then 65, 202. That'd be right about there. 72, 230. Maybe about there. Okay, what's it doing? Doing funny things. 76, 255. 76, 255. 80, 250. Where'd my pen go? That should be an 80 right there. 80, 250. 84, 260. It'd be somewhere around like there. 90, 300. 95, 288. And let's see, 102, 420. 102, 420. Be about here. Okay, so that's the scatter plot. That consists of all the data points. Now what we want to do, we want to draw the what's called the regression line. Now, what was the regression line? So y hat equals, I forgot, 3.9503x minus 49.4. So remember, you had an estimated point. So when x was 82, y was approximated to be 274.5. So let's put in a point 82, 274.5. 82, 274.5. Let's see if we can do that. I'll do that in blue. 82, 274.5. That's going to be about somewhere in here. $82, 274.5. That's that blue point. That's the estimated point. Now, what we can also do, we can use, so this one's the slope right here. We're going to use this right here, which is the y-intercept. That's a minus 49.4, right? If you think about that, not as a positive 49.4, but as a negative 49.4. You can imagine going down here. Imagine being negative 50, even though you don't have negative distances with skyscrapers, right? Skyscrapers are not negative. That can be useful there for finding where the y-intercept would be, right? Negative 49.4 is the approximate y-intercept, so that would be almost at minus 50. So that's just a guideline for drawing the line. So we're going to connect those two dots, the approximate y-intercept and that predicted point, and we're just going to sketch the line between the red here. We're going to just go from this red and go through that point up to the red there. We're not going to actually go down to the left any further. We're not going to go to the right any further outside of those red points. So that's our regression line right there. Now, as far as that blue point that I just invented to help me graph the line, I'll delete that blue point right there, and I'll delete that negative as well. Okay, I'm going to go back. Oops. Sorry. Didn't want to do that. Oops. It's doing the wrong thing for some reason. Okay, there we go. That's better. Yep, so there's your regression line in blue. That's it. It's called the regression line. All right, so that's it for